YouTube. So at 5:17 a.m. this morning, this started flashing red, and at 5:34 a.m. it turned on with no direct sunlight. And as you can see, the sun is coming up, but it's coming in at this sort of angle. And so the sun rises like this and kind of goes across the sky. My panel's south facing like this. So in the morning time, it's not even hitting the panel until it starts getting past right over here on the front side. But I wanted to show you that it's um, basically at 6:14 a.m. This from 5:30 in the morning went from 6 volts up to like 8.6 volts on this DC side, and essentially we're not um, giving it enough juice with the scalar pressure to keep it going. So I added a second one of these in parallel, just like the first one. And well, I wanted to give it more opportunity, so I just made a little capacitor rail. So these are 25 volt 3300. These ones are 25 volt 2200 UF, and these ones are 16 volt 1000 UF. So I have 2, 3, and 2. And then these are just red LEDs, and only this rail is connected to those. And so right now I have the negative connected in parallel, as you can see. And so this is essentially the what comes off of this AD terminal right here, which is the negative of the ground pot. And so what's really weird is if I touch the positive to this, you see only the LEDs light up that are in reverse polarity. And so it's when I do that, what also happens is this red LED status kicks on. I hear the inverter stop humming. It does a fault, and then if I detach it, it turns right back on again. So I guess what I'll do now is I'll just touch this side of the LED briefly, and you'll see this rail light up. And then I'll pan to this, and then you'll see that hopefully be flashing red. So, see that? And that just totally faulted. It's now red, and it's going to recover now. And you can hear it turn back on, and the hum's going now. So yeah, that's a kind of interesting thing about scalar fields and their collapsing magnetic fields is you can sometimes get like reverse polarity and different things like that. And so you got to be careful with this stuff. Always use one hand and use your right hand, and ideally connect your right hand to like your leg that's touching the ground. You know, never give yourself an opportunity to get zapped in a weird way. But yeah, I just wanted to share that interesting find and kind of cool. So let's see, we're at the 10 volt mark on the DC side, and we're just going to measure the input here on this boost converter, if I can hold it. So it's over 10 volts, so I got to go to the 50 mark. Huh, it just dropped below 10 volts now that I'm on this mark. Okay, now we're back to 8.6 like before, at least. Can't seem to hold it to show you. Trying to get my fingers situated. Alright, so there you go. At first it was over 10 when I reconnected it, and then I went to the 50 mark, and then it shot back down, and then it settled there. Not sure exactly why, but it probably has to do with this amount of capacitance as a sink from the scalar field node, which is tapping off of right here. And I just covered this, and as you can see, this resistor is dissipating heat and has taken a little bit of damage here at some point with some sort of surge. Um, yeah, kind of interesting. I have noticed on some occasions that this will flash red, like there's some sort of scalar electromagnetic pulse or something like that. But it does not happen very often. It's only happened a couple times since I've started the experiment. And it might have to do with something similar to this polarity reversal aspect with the flow of energy. Anyways, have a great day.